Welcome to episode 1 of Triquant series. In each video, we'll solve three carefully selected questions for your CAT preparation. Let's begin. Quadrilateral ABCD is a trapezium where AB is parallel to CD, as you can see in the figure. It's given that length of AB is 14 centimeters and the length of CD is 22 centimeters. If the two diagonals AC and BD intersect at point O and the area of the trapezium is 324 centimeters square, then the area of triangle AOD is. So let's try with this method one. I can see in any trapezium, these two triangles, triangle AOD and triangle BOC are congruent. So we'll assume the area of AOD and BOC to be equal and let it be X. Now, let's suppose there is a height called H1 and another height called H2 for the triangle AOB and triangle ODC. In any trapezium, the triangles with the parallel sides as base are always similar. So basically, triangle AOB is similar to triangle DOC. That means AB by CD is equals to AO by CO is equals to BO by DO. That means all are equal to 14 by 22. That is 7 by 11. Now, we know the area of the entire trapezium is 324 centimeters square. So we write 324. And it is basically the sum of area of triangle AOB plus area of triangle DOC and plus the two areas of triangle AOD and BOC, that is 2x. This x is what you're supposed to find. So let's see if we can find AOB and DOC. We know the total height we can calculate very easily from the area formula for trapezium, that is half into the sum of parallel sides, that is 14 plus 22 into the total height. Let this be h, where h is equals to h1 plus h2. This is 324. So easy calculation. This becomes 7 and 11. Take 2 common. 2 is cut here. That is 18. H equals to 324. Let me write this down. That means h equals to, we know 18 square is 324. So 18. H is equals to 18. So H1 and H2 are here. When we had the triangle similar, since the bases are in the ratio, the heights are also in the same ratio, that is 7 is to 11. That means H1 and H2 are also in the ratio of 7 to 11. And since the sum of H1 and H2 is 18, we can say that H1 is equal to 7 and H2 is equal to 11. After finding this out, we can easily calculate the area of triangle AOB and triangle DOC. Let's do it. So area of triangle AOB is half into base, that is 14, into H1 is 7, plus area of triangle DOC, that is half, into base, that is 22, and height, that is 11. We already have 2x here. Now it's just a matter of finding x by solving the equations. So this becomes 49 7 square, this becomes 11 square, 49 plus 121 plus 2x is equals to 324. So 2x equals, this becomes 130, 170. That means this becomes 154. That is x equals 77. That means area of triangle AOD, which is to be found out, is 77. Now this was method one. Another method, or you can call this a shortcut method, a trick, is to reduce the ratio of the parallel sides to its base form So this is, I'll write it again, 14, and this is 22. So AB by DC is 14 by 22, or in the shortest form, it is 7 by 11. Now, if this is equals to A by B, there's a shortcut method. If AB and CD are in the ratio of A and B, then the area of AOB is A square, then area of DOC is B square, the area of AOD is AB, similarly, area of BOC is also AB. So in this method, we can easily see it takes hardly 10 seconds to solve the question. We know A is 7, B is 11, and hence AB will become 77. That is our answer. Let's move on to the second question. In a circle chord AB, which is at a distance of 5 centimeter from the center of the circle, is 24 centimeter long. So I have the diagram for you guys. The chord is 24 centimeter long and it is 5 centimeters away from the center. So we can easily see the radius of the circle is the hypotenuse of this AMO, with AM being the perpendicular and MO being the base. And 5, 12, we know 13 is a Pythagorean triplet. So we know the radius of the circle is 13. Now, let's read the question again. The tangents A and B meet at point P. So we know that this is a tangent onto the circle. That means this is 90 degree. What is the length of the line segment PA? We are supposed to find PA. That is fine. Think let's see the triangle AMO. It will look like this. And triangle PAO, which will look like with AO being the common side, it extends like this. This is the 90 degree. This is the 90 degree. This is angle, let's suppose theta. This is O, A, and P. So this is also angle theta. Angle theta and 90 degrees. So this must be, let's suppose theta 1. Since two angles are equal in a triangle, third angle must be equal. This is also theta 1. So we can say that these two triangles are similar. Since they are similar, we can say in this triangle, side opposite to side opposite to theta, theta is here, is AP. So AP by side opposite to theta in the smaller triangle is AM, is equal to, we can say, side opposite to theta 1, and here also side opposite to theta 1, that is MO, AM by MO. Now we just need to substitute the values. AP is what we are supposed to find. So AP, AM, we know it's 12 is equal to AM again. AM again, it is 12. Sorry, in triangle APO, the side in front of theta 1 is 13. This is 13. So we'll take AO instead of AM, that is 13 by MO. MO, the distance from the center, that is 5. So it's just calculation now. AB equals to 12 into 13 by 5. And I think this will be 144 and 12, that is 156 by 5. And if you're supposed to write it in proper fraction, I think this would be 31, that is 155, 1 by 5. This should be our answer, and I think this is your option C. Let's go to the third question. There are three square-shaped plots of land A, B, and C. I've written it, drawn it for you here, with lengths of each sides in meters A, B, and C. respectively, such that A is smaller than B is smaller than C. The sum of these areas of these three plots is 600 meters square. So basically, this is A square, the area, this is B square, this is C square, and the sum of these three are 600 meters square. Now, there are three rectangular plots P with the length as B meters and breadth as A meters. Okay, so for P, the area would be AB, and Q length C meters and breadth A meters. Okay, Q is AC, and for R, we can see C meters and B meters, that is BC. AB, AC, and BC are the areas for PQR. Now, which of the following cannot be the sum of areas of PQ? So we know that A is less than B, B is less than C. So if we subtract A minus B, this is going to be less than 0. But if we'll square, any negative number will become positive, that is greater than 0. And B minus C again, it will be negative. But if we square it, it becomes positive, that is greater than 0. And C minus A is again positive, or you can write A minus C, that is negative. Still squaring it will give us greater than 0. So if adding three terms which are greater than 0 definitely gives us greater than 0. So now if we open up the brackets, so we'll get A square B square here. So A square plus B square minus 2AB. We'll have B square plus C square minus 2BC. We'll have A square plus C square minus 2AC greater than 0. Now we can collect the common terms and write we have A square here and here, B square here and here. So we have two terms of A square, B square, and C square. We'll write it like this: A square plus B square plus C square all multiplied by 2 minus 2AB plus BC plus CA is greater than 0. So we'll add 2 into AB plus BC plus CA on both sides, and we get 2A square plus B square plus C square greater than 2AB plus BC plus CA. So 2 gets cancelled. A square plus B square plus C square we know is equals to 600. So 600. So AB plus BC plus CA, which is nothing but this area of P, Q, and R. So the sum of P, Q, and R must always be less than 600. So which of the following cannot be the sum of areas? Both 600 and 620 cannot be the sum of areas as it is less than 600. It can be 580 and it can be any number less than 600.